Hi, I'm Professor Melko, Chemistry PhD, and your chemistry professor. Today we're going to talk about adding and subtracting measurements and how that affects significant figures, as well as multiplication and division and how that affects sig figs. So let's jump into the lecture. So we've talked about significant figures and rounding them off in previous videos. Today we're going to talk about, well, what happens now if you have two separate measurements, each with their own level of uncertainty, and so their own level of significant figures, and now I have to add those things together. So imagine you had to determine the total mass of something by adding up its various components. So you weigh out component 1, maybe on a really old balance, you get 114.3. Then you weigh out another component on a different balance, you get 0.75. Maybe you weigh out a third component, you get 0.581. Right? And each of these have a different level of precision to them. One is out to 1 decimal place, 2 decimal places, and 3 decimal places, respectively. Now you have to add them all up for the total mass. You get 115.631. But how many of these numbers are significant? Turns out the rule for addition and subtraction is as follows. Your answer has got to be limited by the value with the most uncertainty, which I know is a little confusing, but bear with me. So this first measurement here, 114.3, right, is not known out to the thousandths place, right? I'm going to write zeros here, but we don't know those places. So there's no way my final answer can be written out to the thousandths place. This one cannot be significant in the final answer because I didn't know it in this measurement. So that's really the rule, is you count the fewest number of decimal places. Here, the first answer only goes out to the 10th place, so I have to truncate my final answer to that 10th place. I still have to keep in mind whether I need to round this 10th place or not by considering this first non-significant digit. It's less than 5, so I just drop these non-significant digits. If it was 5 or greater, I would round up the 6 to a 7. So my final answer here is just going to be 115.6. This is the rule you're going to use in all addition and subtraction measurements, right? Whether you're adding them all up or subtracting them all or adding some and subtracting others, at the very end, your final answer can only go out to the number of decimal places of the fewest decimal places in the things you're adding together or subtracting together. Let's try some examples. So subtract 0.25 centimeters from 11.5 centimeters. You can do this on a calculator or in your head. Should get 11.25, as I do on my TI-83 Plus, the absolute best calculator, hands down. Convince me otherwise. So I get 11.25, right? That's what the calculator spits out, but that's the math I can also do in my head, 11.25 centimeters. Is that my final answer? Maybe. I have to consider the decimal places of the things I'm adding and subtracting together, right? I added 11.5 and 0.25. That's what, or subtracted them, excuse me. That's what gave me this 11.25. And just like in the previous example, I see that this first number is only out to the 10th place, so I have to sort of truncate this final answer out to the 10th place. This non-significant 5 here means the 2 gets rounded up to a 3. Remember, if this first non-significant figure is a 5 or greater, I round up the previous digit. Okay, so here my final answer should be 11.3, not 11.2, not 11.25, but 11.3 due to rounding. If you've forgotten the rules for rounding significant figures or the definition of significant figures, go back and watch the previous videos. So that's addition and subtraction. Confusingly, multiplication and division has a different set of rules, so make sure you keep these separate. When multiplying and dividing, your answer is limited to the value with the fewest significant figures. Has nothing to do with decimal places, right? So addition and subtraction, decimal places, multiplying, dividing, just fewest sig figs. Right, so imagine we're multiplying 7.28 by 4.6. The calculator spits out 33.488 centimeters squared. Now, be impressed if you could do that in your head. This one, I'm going to use a calculator. I get 33.488 centimeters squared. Now I have to look to the things I'm multiplying together. 7.28, each of those numbers are significant, so that's 3 sig figs. 4.6, 2 sig figs. I choose the lesser of these numbers, 2 sig figs. My final answer better only have 2 sig figs. The 3 is significant, the 3 is significant. All these other numbers are not significant because I have to limit it to just 2 sig figs. So my final answer here, I drop all these non-significant figures and report 33 centimeters squared. Let's try an example. Divide 62.3 by 8 and report your answer. You can pause the video here to do it yourself. I'm going to continue to work ahead. (62.3) divided by 8.0. I'm going to use my handy dandy calculator for this one. I get 7.7875. I'm just going to write out all the digits in my calculator. Then I'm going to be the one that determines where to round this off. It's multiplication and division. So I know I have 3 sig figs and 2 sig figs. I have to limit my answer to just 2 significant figures. The 7 significant, this 7 significant. So those are the ones I keep. I look to the first non-significant figure, the 8. That's a 5 or greater. So the previous number gets rounded up and I get 7.8. Only 2 significant figures. Now, don't forget to include your units. It was grams divided by milliliters. So the final answer here should be 7.8 grams per milliliter, a unit of density. So that's the final answer there. So these were some examples on addition, subtraction, multiplication, division. What are the different rules for significant figures? Next time we'll get into scientific notation and powers of 10. The previous videos were on significant figures. Go watch some of those. Feel free to subscribe to the channel on YouTube or go watch me on Twitch every week where I stream office hours and discuss the latest science news. See you next time.